Hi students, so today I'm going to talk about the chapter quadrilateral, and within quadrilateral I'm going to discuss the different kinds of quadrilateral. What are the four kinds of quadrilateral we study in class 8? One is the parallelogram, second is the rhombus, third is the trapezium, and fourth is the kite. So why I have made all these figures on one page is that we can do the comparison and can see the differences between each of the shapes. So starting with the parallelogram, the word parallelogram, means that opposite sides are parallel to each other. Opposite sides are parallel to each other. Now, if you remember in class 7, we had studied that if there are two parallel lines and then there is a traversal line, which cuts them, then their internal angles, the sum is 180, which means if this is angle 1, this is angle 2, then the sum of 1 plus 2 is equal to 180 degree. Similarly, if this is angle 3 and this is angle 4, then 3 plus 4 is equal to 180. This is what we studied, in the last year in class 7, that if there are two parallel lines and one traversal line crossing both of them, then the internal angles, the sum is 180. Second thing, in the parallelogram, the opposite angles are also equal, which means 1 is equal to 4 and 2 is equal to 3. Opposite angles, right? Opposite angles are equal. Third is that if you draw the diagonals, just look at the shape. These diagonals bisect each other, which means this is equal to this and this is equal to this. Another important property, I again repeat, if you draw the two diagonals, the diagonals bisect each other, which means this line is bisecting this line. This line is bisecting this line. So diagonals bisect, right? The diagonals are bisecting each other. Now, fourth is that when we are drawing the diagonals, meeting the two opposite ends, even the angles are getting bisected, which means if this is A, this is B, this is C, and this is D, AB diagonal is bisecting the angle DAC. This whole angle is being dissected by this diagonal AB, right? So diagonals bisect the angles, right? Diagonals. So these are the properties of a parallelogram, right? I don't have to repeat. You can always rewind and listen to me again. Second comes the rhombus. Why I have made rhombus next to parallelogram? Because most of the properties are very, very same. What are the properties which are same? Opposite sides are parallel. This line, again, I'll name it ABCD. So AB is parallel to CD, right? And AD is parallel to BC. So opposite sides are parallel, right? Second property is that all sides are equal, which means AB is equal to BC, BC is equal to CD, and CD is equal to AD, right? AB is equal to BC, BC is equal to CD, and CD is equal to AD. Third, again, very similar to parallelogram, the internal angles, the sum will be 180 degree. Now listen to me, 1, 2, 3, and 4. So 1 plus 2 is equal to 180. 3 plus 4 is equal to 180. Interesting, 1 plus 4 is equal to 180. And 2 plus 3 is also equal to 180. all because of the parallel line properties, which I just explained it to you in this diagram. Very interesting. 1 is equal to 3, 2 is equal to 4, 1 plus 2 is equal to 180, 2 plus 3 is equal to 180, 3 plus 4 is equal to 180, and 1 plus 4 is equal to 180. I hope you could understand this. Opposite angles, as I said, are same. So 1 is equal to 3 and 2 is equal to 4. Now the most important, which is different from parallelogram, when we draw the diagonals, one, it definitely bisects, but the most important is they bisect at 90 degree. Diagonals bisect each other at 90 degree. This is the differentiated property from the parallelogram, right? So this is on the rhombus. Now let's discuss the trapezium. What is a trapezium? Trapezium is different from these two, that only two opposite lines are parallel to each other. So again, A, B, C, D. Only the two lines AB and CD are parallel to each other. The other two sides are not parallel to each other, right? Now, there can be two kinds of figures. One, where the non-parallel sides AD and BC, in one case, they are not equal. Not equal means this can be, if I make a figure like this, then this line is not equal to this line, right? Had I made a trapezium like this line, but there is another kind of trapezium where AD is equal to BC, which is the most important trapezium, which is called isosceles trapezium. Isosceles trapezium. What is the meaning of isosceles trapezium? That yes, these opposite sides are parallel, but the non-parallel sides will be equal to each other, just like the way we had studied about isosceles triangle in the last year, where if two sides are equal, remember isosceles triangle? If two sides are equal, their base angles are also equal. A, B, and C. The base angle, angle B, is equal to angle C in case of isosceles triangle. Similarly, in case of the trapezium, also the base angle, these are the base angles. And also, these are also called the base angles. There are base angles on the bigger parallel line. There are base angles on the smaller parallel lines. 1, 2, 3, 4. So 1 is equal to 2, angle 1 is equal to angle 2, and angle 3 is equal to angle 4. This is what you have to remember, that the base angles, this angle is equal to this angle, and this angle is equal to this angle. Another property, because these are parallel lines and these are the traversal lines, angle 1 plus angle 4 is equal to 180 degree. Angle 2 plus angle 3 is equal to 180 degree. Yeah, I hope you are getting it. Angle 1 plus angle 4, 180, angle 2 plus angle 3, 180. But the base angles are same because this is an isosceles trapezium. Right? This is an isosceles trapezium. Another property is that if I connect these diagonals, diagonals are equal to each other in case of isosceles triangle, which means AC is equal to BD. Right? This is what the trapezium is all about. There are a lot of questions on the trapezium. So we'll do. But before that, let me talk about one more shape, which is called the kite. Kite is actually a kite shaped, right? If I draw the two diagonals, then it actually takes the shape of a kite, right? It actually takes the shape of the side, takes shape of the kite. What is the feature of kite? Kite, if you can just make out, with the original kite, the two sides adjacent to each other are same. This side is equal to this side, and this side is equal to this side. Let me just name this A, B, C, D. So AD is equal to AB, AD is equal to AB, and DC is equal to BC. So this is unlike them, unlike all these figures, there are no parallel lines. So please don't get confused that AB and DC are parallel to each other. No, they are not parallel to each other. Another point, again, these diagonals AC is perpendicular to DB. Both diagonals intersect at 90 degree to each other. So this angle is equal to 90 degree. They cut each other at 90 degree. And when they cut each other, supposing this point is O, so it bisects, the longer diagonal bisects the smaller diagonal, which means DO is equal to OB. DO is equal to OB. Anything else left? Yes. One more important thing. Angle D, the angle which is formed by the smaller and the bigger line, which is angle D, and the opposite angle B, they are equal to each other, which means angle ADC is equal to angle ABC. But is this angle equal to this angle? No, which means angle A is not equal to angle C, right? So I hope, I could explain exactly the differences between the four shapes of quadrilateral. All these are important because there can be innumerable number of questions which can be formed in each of them. I hope you liked it. In case there is any confusion, you can always rewind and can see the properties. See you in the next video.